Hello everyone, this is Ibrahim Zafar working as Assistant Professor in EEE Department, MITS Madanapalle Institute of Technology and Science. Today I will give the deliver lecture on the concept of microgrid. It is a very important topic and concept in electrical engineering. So I will explain each and every topics related to the microgrid in shorts. So today we will see what the content I am going to deliver to you. So next, here it is the contents of flow of our PPT that first we will discuss what is the microgrid. Second, I will explain how does microgrid work. Third, we will discuss about the how does a microgrid connect to the grid or conventional grid. Next, we will discuss the composition of microgrid. That means what the components we require to make the microgrid. Next, we will discuss classification of microgrid. That means types of microgrid. How many types we will discuss in detail. Next, classification of microgrid as a capacity. That means megawatt capacity we will discuss. Next, difference between the conventional as well as your microgrid, conventional grid versus microgrids. And last, we will discuss advantage and disadvantage of microgrid. So in this video, so many things, so many topics we are going to cover. So you will see and listen carefully. You will understood so many things related to the microgrids. So first you will understood what the microgrid. So microgrid is a small scale power grid that can operate independent or collaboratively with the other small power grid. What the meaning of that? So microgrid is the one of the place where we have to generate the power as well as we have to distribute or connect to the load at the same place. That means it is the autonomous type power generation and transmission distribution system. As the conventional power system, there is the separate power generation system. After that we transmit power from generation to the load center. So it is a very complex system. First we have to generate to some place where the sources are available. After that we have to transmit the power. Next we have to distribute the power to the different loads and consumer. But in that microgrid, what happened, where we have to generate power, where loads are present, where consumers are present, same place we have to generate the power and we have to deliver or send to the loads. That means where the power required at the same place we have to generate and send to the loads or connect to the loads. So it is the small scale power grid. It work independent. That means it not required to depend any other stations, other grids, all these things. Here complete setup, that means generation or the control system, backup system, all these are available at a same place. So such a combination of system, that means generation, transmission, distribution, load, storage system, all are present together. So such system are known as microgrid systems. So I hope you understood what the microgrids. Now the second point here mentioned, it work independent or with the connected to the conventional grid. Okay, that means here if we generate the power, so either we have to send that power directly to the load. If more power we are generating apart from our load, our consumer demand, that means more than our consumption, then we have to send that power to the conventional grid system. That means we can also sell our powers to the other person or other grid system. So that the advantage of microgrid. The second thing, any small scale localized power station has its own generation. That the second definition mentioned here. Any small scale localized power station that has its own generation and storage resources and definable boundaries can be considered as a microgrid. That means a localized power station where all the things are present together. So such system where all the generation and storage, all these things are present in the same place, same localization. So such system is known as your microgrid system. So I hope you understood what the microgrid. So next we will go further. So here very important diagram which shows about your microgrid. So if you understood that diagram clearly, you can understood the what the microgrid and how it works. So here you will observe that here with the help of diagram you can see here all these things, your natural gases, fuel cells all present here, and next here microgrid manager are present, controllable loads are available, utility grid or conventional grid you can say it also present, and here photovoltaic system is there, backup system is there, energy storage. That means you can see with the help of that diagrams all the systems, that means generation system with the help of photovoltaics or your natural fuel system, and your power backup system, utility grid, controllable loads all are placed together. So such system where all the things, all the power system elements, equipment present together at a same place, so such type of arrangement, such type of place is known as microgrid. And one more important point you have to remember in the microgrid, mostly in the microgrid generation we are prefer the photovoltaic system, that means renewable energy sources, either we are prefer mostly photovoltaic or we will prefer the your wind power generation. That means we have to prefer the renewable energy sources. Already we know that it is in the demand, and it is very important nowadays renewable energy sources, there is no pollution and very too much advantages, we will discuss later what the advantage of microgrid. So here mostly we will prefer the photovoltaic system. So with the help of photovoltaic system we will generate the electricity, that electricity we can send to the consumer point. Here you will see consumer point we can send, or we can send if more power we are generating more than our requirement, then we can send it to the utility grid, or you can say your conventional grid or conventional power system. So this combined system, and in the microgrid also we required the backup storage system, that means battery system, and also one important factor, one important device, that is the controllable loads, how much loads, according to that we have to generate power and we have to send to the loads. So this all component present together, so such system is known as microgrid. So next we will see what is the microgrid. So here it is again mentioned, a microgrid is the local energy grid with the control capability, which means it can disconnected from the traditional grid and operated autonomously. So here autonomously means it not depends to any other generation system or transmission system. One important, that first line if you understood, then you can easily analyze what the advantage or why we are going to prefer the microgrid. It is the autonomous operation, like our institute, our MITS is working autonomous, it is not depend to any other institution, any other engineering calling. So like that here our microgrid system is autonomous, here it is not depends to any other generation system. Here itself we are generating the power, we are sending to the load, we are managing, or we can control the power, and we can store the power, all the things present together. So it is one of type the autonomous system. So next here you can second point you will see, second point, a microgrid, a strategy that the integrate local wind or solar sources. That means here we will integrate or we can add the power wind and solar resources. So already I mentioned mostly we have to prefer in the microgrid wind power or solar resources or solar power system. Why? Because it is now it is in demand. Why? Because it is renewable energy sources, there is no pollution, there is the we can in the future also we can generate more power from wind and solar, it is the free sources available in the nature. So like that I hope you understood the microgrid. Here microgrid should be capable of handling both the normal state, that is grid connected, and the emergency state isolated operation. That means both the cases we can operate the microgrids independent, as well as we can connect or we can give the power to the other other utility grids, that means conventional grids. So these things I hope you understood. So next, how microgrid works. So to working the microgrids, we need some components. So here, in order to work microgrid, must include essential components. So what the essential components? So we have to generate the power in the microgrid. First component is required the generation. So how to generate the power? With the help of, here you can see, photovoltaic panel, wind turbines, cogeneration, heat pumps, and the biomass plants. So many things, so many options. That means all renewable energy sources we can use to generate the electricity, to generate the power. So that the option, that means here first thing, first essential things required to generate the power with the help of renewable energy sources. Next things we require to work the microgrid is storage system. In the conventional or the what we are using power system nowadays, in that no storage system, but here we are using as a generation our photovoltaic system. So in the night time or rainy season, that solar radiation are not available. For that purpose also we required a storage system. That means in the microgrid system must we have to add the storage system. So here we are adding the batteries and other storage system. The third thing we required is smart management. So without management we can't fulfill the load requirements. So here we need management system, which according to the load we have to generate the electricity and we have to deliver to the load. So this, all these things, how microgrid works. So next we will see how does microgrid connect to the grid or utility grid or main grid, or you can call conventional grid. So which grid nowadays mostly using, that the conventional grid. Now how we can connect the microgrid to the main or conventional grid? For that purpose we have to remember, or we have to focus few things, that when we are going to connect the microgrid connect to the main grid, at a point common coupling that maintain the voltage at same level. That means already you know the synchronization. That means here also we require synchronization when we are giving or connecting the microgrid to the main grid. At that time we have to see the synchronization. That means our voltage should be same as the conventional grid, then only we have to connect. Otherwise we cannot connect, our whole system will be becomes unstable. So for stable operation we required a stability. That means the voltage should be same, frequency should be same, and the phase angle should be same. This, all these things we have to see when we are going to connect microgrid to the main grid. Next, while we are connecting the microgrid to the grid, so at that time we can switch can separate the microgrid from the main grid automatically or manually. Both the function are available. We can connect automatically or manually as per our requirement, as per our demand. So next thing, composition of microgrid. That means what the components are available in the microgrid. So first composition, first element is DG, that the distributed generation system. So in that already we discussed. So we required generation system in the microgrid. That for that purpose we required, mostly we have to prefer the solar system. That means here you can see PV system we are prefer. Other renewable energy sources we can also prefer, we can also use. So that is the wind power plant we can connect to the microgrid, or fuel cell, or combined heat and power system. So many option renewable energy sources are available. From that we can generate the power and we can connect in the microgrid. Second thing, second composition of microgrid is load. Without load microgrid will not exist. That means microgrid means we have to connect all the system. That means generation system, load system, EC system, ES system, control device. This all four devices, four composition are required in the microgrid. So second thing is load. That means consumer should be there while we are constructing the microgrid. There is the EES, that means include the physical, chemical, electromagnetic form of storage system. So storage system also required in the microgrid. And the fourth and the important thing is control device. So without control device we cannot manage the microgrid. Why? Because every time solar radiation are changing, our wind pressure is changing, so for that purpose that controlling device is most important, as well as load also vary time to time. So this all these things are managed with the help of control device. So these four elements, four composition are present in the microgrid. So next we will see here classification of a microgrid. So there are three types. The first one is the AC microgrid. So in that, with the help of diagram you can easily see here the utility grids are there. It is connected through the distribution transformer, and here bypass switch is there, and mainly you have focus on the bus bar. So in the AC microgrid we are using the AC bus bar. So AC bus bar means what the power is generating. That means if power is a DC generator, first we have to convert into AC, and then we have to feed to the AC bus bar, and we can send to the utility grid or consumers. So such type of system where we are using the AC bus bar, and from AC bus bar we are giving supply to the loads or utility grid. So such system is known as AC microgrid. So I hope you understood what the AC microgrid. So next you will see the DC microgrid. So already you know in the photovoltaic cell we are generating the DC system. So here if we are generating DC system or DC photovoltaic system we are using, so no need to convert AC to DC. Directly we will feed that DC supply to the microgrid, and that DC supply is connected to the load. So if load is DC, then okay, no issue. But if load is AC, so first we have to convert that DC supply to AC, then we have to feed to the load. Similarly you will see the grid system. So already you know grid, that means conventional grid or utility grid is the AC supply system. So for that purpose here one converter is there which convert DC to AC. After that here transformer, then we have to feed to the transmission line or utility grid. So when a DC bus bar is using in the microgrid, so such system is known as DC microgrid system. So sorry. So third and the final system is the AC and DC microgrid. So both the things are available in that microgrid. So you will see in the diagram it is clearly mentioned or clearly visible both the bus bar available. Both AC feeder bus bar are available and DC feeder or DC bus bar are available. So while you are generating supply through the any photovoltaic system or any other system, we can convert either AC or DC as per our requirements. So if load are suppose here AC load, so we can give the supply from AC feeder or AC bus bar. If load are DC, that means for electrical vehicles, so for that purpose we need supply from the DC bus bar. So from the DC bus bar we can take the supply and give to your electrical vehicle. Similarly if DC loads are there, any loads which is using DC, directly we will feed from the DC feeders. So from that system we can take that the more flexible system, more reliable system, both AC and DC are present together in such system. So here AC feeder as well as DC feeder both are available. And one more important thing here, if you are using suppose photovoltaic system for generation, that means DC supply. So if we are giving supply to the AC feeder, so at that time we need some converter, that means we convert from DC to AC. If only DC required, so directly we will feed to the DC. Next, if AC we are generating through the any wind power plant or any other, if feeder is DC, then we have to convert that AC supply to the DC supply. So like that we have to convert as per our requirement. So here from the bus bar you can see here utility fact, that means uh, utility grid also available. From that bus bar we can also give supply to the utility grid or the main grid. So I hope you can understood very well how to use that AC and DC microgrid system. It is the, as compared to AC and DC, it is more reliable system and most prefable system, AC, DC microgrid system. So three type of microgrid we discussed. First AC microgrid, second DC, and third one is AC DC microgrid. Now we will see next that the classification of microgrid as per capacity. Okay, so here clearly mention different generation system, that means how much power it is generation. According to that we have to classify the microgrid. So if it is generating less than 2 megawatts, so it is called the simple microgrid. It is 2.2 to 5 megawatt, so it is corporate microgrid. Like that we have to convert as per generation capacity. So you have to see that how many types are microgrid available as per their power ratings. So next we will compare with the conventional grid versus microgrid. So already I mentioned that conventional grid we can also call the utility grid, or we can also call the normal grid. Okay, but here mostly we are focusing on the microgrid. So now we are going to comparison with the microgrid versus conventional grids. So first you will see here, first point and very important point mentioned here, that the efficiency of conventional grid is low compared to microgrid. You can understood, if you listen up to here carefully, you can understood why it is efficiency is less in the conventional grid and why more efficiency in the microgrid. First and important thing you will remember here, in the microgrid completely we eliminate the transmission system. Why? Because microgrid means where power is required, where loads are available, where consumers are available, at the same place we are generating power. So obviously same place we are generating means here what the transmission losses are available in the power system, conventional power system, that totally eliminated. So obviously in the conventional power system and conventional grid system there is the more power losses, and the microgrid system there is the more efficiency available, less power losses are available. So here first and important point is efficiency of conventional grid is low as compared to microgrid. Second, and the second point, large amount of energy in the form of heat is wasted in the conventional grid. That also you will understood by with the help of first point. Why? Because here no transmission line in the microgrid, that means no transmission losses, no heat is produced in the transmission. That means what the in the normal conventional grid system large amount of heats are wasted, and large amount of your electricity are wasted in the form of heats, but that heats are eliminated in the your microgrid. Why? Because we are generating at a same place. The third point, power source in the microgrid are small and located losses to the closest to the load, where loads are available, same place we are generating the power. So power sources in the microgrid are near to the loads. So these all are very important points as compare or advantage of microgrid as compared to conventional. And also you have to remember, in that microgrid already I mentioned, here we are using the non-conventional energy sources or renewable energy sources. Again it added more advantage in the microgrid. In the conventional grid system mostly supply comes from the conventional power plant, where the most pollution is there, more losses are there, and more cost also there. So that all disadvantage eliminated in the microgrid. So next, here advantage of microgrid. I hope up to that you understood what the microgrid, what the classification, and advantage also you can understood. So here microgrid generation resources can include the fuel cell, wind, solar. These all are the renewable energy sources, or that means non-conventional sources. In the upcoming future also we are not worried about that fuel or sources are available or not. Why? Because other sources are depleting day by day, but our renewable energy sources are every time available in the nature. So provide, next point, provide the power quality, reliability and security. That also important point. In the conventional system there less reliability, here more reliability. Why more reliability? Here we are eliminating the transmission system, we are generating power same place. That means here what the chances of fault occurring in the transmission line, that totally eliminated. Normal power system mostly fault occur in the transmission generation system, but here transmission are not available. We are generating at the same place. That means here more reliability we will get, continuous supply we will get, and here more security in the system. So cost also, here cost is less and efficient. And by product heat from generation source, such a micro turbine could be used. That means here losses also eliminated. Like that, so many advantage added in that microgrid system as compared to the conventional. Now here disadvantage of microgrid, and that also you have to know what the challenges in the microgrid. Why? Because up to that you only listen advantages and what the benefit in the microgrid, what is microgrid, this all these things are very good, but here some challenges are there, some disadvantages are there in the microgrid system. So first challenge, first disadvantage is voltage, frequency, power, quality are three main parameters that must consider and the controlled a acceptable standard um, power energy balance. That means for balance the system to synchronization purpose, what we have to require, we have to balance that all voltage, frequency and power system. But already you know in the renewable energy sources, that means solar or wind, that voltage, power, frequency, this all these things are vary a time to time. That means in the sunny days you are getting more sunlights, in the rainy days you will get less, in the night time you will not get any solar energy. So continuously it is vary. So here more challenges and also load is vary. So here control system is more important in the microgrid to control all these things, voltage, frequency, power, to make the system balance. Okay, here also second thing, second challenge or second disadvantage in the microgrid system is electrical energy need to be stored by battery banks. In the conventional system, just we have to generate the power with the help of transmission, we send to the loads. There no needs to store the energy, store the power. But in the microgrid we have to store the energy. Why? Because here we are using the renewable energy sources, solar and wind. So in the night time we are not getting solar energy, so we have to store. So here storage system also required, so we have to maintain storage system, we have to spend more money to storage system. This all are challenges or disadvantage in the microgrid. Third is synchronization. In the first point itself I mentioned synchronization is also challenge in the microgrid. Microgrid protection is also one of the important challenge. So these all are challenges or disadvantage of microgrid. So we have to improve or overcome. That means we have to work in this field. We have to improve or we have to reduce this disadvantage. We have to rectify that challenges and we have to improve the microgrid. Why? Because in the upcoming generation we need more renewable energy sources, more power generation, and other conventional sources are depleting day by day. So we have to work on the microgrid. It is most important in the upcoming future. So we are working together and we have to rectify this disadvantage. So I hope up to here you clear all these things. So these are the references, from that we collect the data and images. So up to that that means conclude that all these things, that means we discussed what the microgrid, what the element present in the microgrid, what the advantage of microgrid, what the challenges in the microgrid, what the classification of microgrid. So many things we understood in this video. I hope you enjoy this video and you learn from this video. So we will meet in the next video. Up to that, that's all. Thank you.